Okay, I think now we are back. So sorry for the technical glitch. I don't know. So this is how we will start. We will start with the what is RFID and bit of history and moving on to the other important things which you can see about different tags, readers, antenna, radio frequency, operating frequencies. It's a rather long presentation, so some of the topics I may go a little fast. Then RFID printing applications, retail and store visibility, moving to e-pedigree with RFID, the standards for RFID, advantages. So here we are. What is RFID? RFID, as the name suggests, is a radio frequency identification device. And RFID is a technology that uses radio frequency waves to transfer data between a reader and a movable item to identify, categorize, track, trace, and whatever. RFID is fast, reliable, and does not require physical sight or contact between reader, scanner, and the tagged item. That is the biggest advantage, that without seeing it, you could detect it and use it. Typically, this is how the whole RFID setup would look. That this is a customer service, purchasing team, accounting, sales, data collection, deliveries. So here, this is the RFID point. This is manufacturing RFID point, packaging. So you can have the RFID reader at different places, and you can scan them. So it is good for warehousing, inventory control, record of deliveries. Historically, there are different stories behind it, but RFID is a wireless system that works in conjunction with the company's information technology infrastructure to facilitate the tracking of the objects. That is the key thing. Some people say that this was used by the Russian government in 1945 to espionage. I don't know. But during the World War II, UK used RFID to distinguish returning English airplanes from inbound German ones. Radar was only able to signal the presence of a plane, not the type of the plane. So there has been different usage. You can see the development. And now coming back to the RFID technology introduction, as mentioned before, it's a identification through radio wave based communication. Requires no line of sight operation. Operations are very fast. Frequencies ranging low frequency 125 kilohertz to ultra high frequency 915 megahertz and beyond. RFID tag consists of an antenna, chip. Tag can be active or passive. It can be read only, or it can be like floppy disk drive we used to have read only or rewritable. It is available in the different shapes and sizes. A typical RFID reader kit consists of radio circuitry, RFID antenna for generation and detection of radio waves, computational device for basic processing and filtering of signals, software library deployed on a PC interacting with reader device. Automatic technology description, automatic identification, auto ID, the technology used to help machines identify objects and provide information about those objects through automatic data capture. And then the data must be converted into a digital form to be used by computer systems. So examples of auto ID includes barcodes, smart cards, voice recognition, retinal scans, OCR, and RFID. So RFID is one of auto ID, And RFID is a generic term for the auto ID technology that use radio waves to automatically identify individual objects. Which I mentioned before briefly, it has three parts: reader, transceiver with decoder, and transponder. What constitutes an RFID system? One or more RF tags, two or more antennas, one or more interrogators. You will see about this more later. One or more host computers, and appropriate software. Without software, nothing happens. You see components of RFID. This is the application program interface API, RFID API software communicates with the RFID reader. Here is the reader, and here is the antenna. This is the chip, and this is another pictorial telling you this is the asset tag, and there would be a antenna, and from where this will be host and customer's MIS system. So using this, we can identify application commands. Interrogator will have typically encoder, decoder, stack driver, mapping rules, logical memory, everything. So which is there, and this is the RF tag. So this is basically typically the part of the reader, and then partly this will be reader and will go into RFID operations. So you know you have a reader RF module, an antenna in this, and then host computer. So this is a sequence of operation: host, manager, readers, and issues commands. Reader and tag communicates via RF signal. Carrier signal generated by the reader upon request. Application. Carrier signal sent out to the antennas. Carrier host. Carrier signal hits the carrier signal. So as that you can see how the RFID, typically it is sandwiched in a label or a plastic card or some tag. RFID label, you will have, say, this is the liner, there would be carrier substrate, there would be an adhesive. Then on this carrier substrate will be the chip printed, which will have typically antenna and rest of the things. And then this is the label. This can also be done embedding in a plastic or like a credit card kind of thing, other plastics, different ones. You can also put it somewhere, some injection molding, caps, so many different things. Some of other types where it is used, it's on pallets or cases of product, company assets or personnel, pupil, livestock, pets, and RFID film label, or this is on the key ring. So there are different types of, and this is the typically the circuit looks. What are the tags? The tags is a transponder which receives a radio signal and in response to it sends out a radio signal. So tag receives and sends a signal. Tag contains an antenna and a small chip that stores a small amount of data. Tag can be programmed at manufacture or on installation. Tag is powered by the high power electromagnetic field generated by the antennas, usually in the doorway. You will see sometime when you're going somewhere in the big mall, you have those two big things standing. And if we have something, the RFID tag, which is not deactivated, so the moment we pass through it, they will start making noise. So they are getting the power from the antennas. And the field allows the chip antenna to reflect an extremely weak signal containing data. Collision detection, recognition of multiple tags in the read range. So when you have, say, hundreds of items stocked up into a trolley and you want to take it out, that can also be done with the help of RFID. The tags could be read, write, depending on the uses, and it can typically go from 64 bits to 1 kilobyte. RFID system basics: tags, ID only, read only, active program, programmable database pointer. So write once, read many times, that is also possible. Mission critical information, read, write, in use, programmable, or different possibilities. So these are the different types. Basic types: active tag transmits radio signals, battery powered memory, radio and circuitry, high read range 750 plus. Passive tag reflects radio signal from the reader powered, not battery powered. Shorter read range, maybe about 20 feet, starting from 4 inches. Variations can be within this. It could be the different memory and read only, read write, or write once, read many times, and different ones. So this is what I already explained you shortly before. And then semi-passive tags are the like passive tags but contain batteries that allow the tag to perform other functions, such as monitoring environmental conditions, for example, monitoring the temperature. So there are few other things can also be incorporated. So typical characteristics of RFID tags, which you see in the table: passive tags, power supply external from reader; semi-passive, internal battery; active tags, internal battery. Different read range, different memory, cost can change. Active tags, though I written about $20 or more, but it can be still cheaper because a lot of developments are happening and the costs are coming down. This is just to give you an idea. Life of a tag: the passive tags has a high life because there is no power supply required, so 20 years or maybe more. Semi-passive, typically 2 to 7 years or maybe more now. And active pad, I think 5 to 10 years, or could be more, but this is just to give you an idea. Readers, there are different types of readers. As you can see, and you might have already seen, they can be in different shapes and sizes depending on the uses. Then what is RFID readers and where are they fixed? They can be on the entrance and exit of a building, of a mall, of a shop, in a library when the books are being tracked. And it can be in the mobile phone or handheld devices. So frequencies: RFID is fundamentally based on wireless communication. Frequencies from 300 kilohertz to 3 gigahertz. RFID operates in unlicensed spectrum space and sometimes referred to as ISM, industrial, scientific, and medical. These are the different operating frequencies and characteristics, like low frequency, high frequency, ultra high frequency, and microwave. So typical RFID frequencies: 125 to 134 within this useful RFID. Out of the low frequency RFID, use a 125 to 134, like that, the different ones. And depending, how do we select which one? Depending on the data transfer rate that we need. This is same, more explained. And like any other technology, this also has their own issues for implementation, because for a proper implementation of RFID, standardization is one of the key things. And then legislations concerning the country regarding UHF, physical characteristics of RFID, and what is the available technology in the area. And though there's a lot of knowledge available, but still there's a lot of experience required, and then there's a lack of knowledge in some places. So it's developing. Typically, how do you implement RFID? So I think that's a good one which you all would be interested to know. It's a 12-step process for RFID implementation, and I'll take you one by one. It starts with building your team and then defining business requirements. So the team is very, very critical with the cross-functional team with executive sponsorship, and it is a enterprise level changing technology which requires interactive collaboration from each operating. It's not that we just buy RFID and just implement it. Then we got to define the requirements, and then we develop a RFID roadmap to connect the dots. Then we have to analyze the environment, determine data streams that we will be having, work on data integrity, security, and recovery plans, initiate proof of concept plan based on measurable criteria, and an initial RFID implementation plan. It's like a test run. We have to do it. Then select pilot product criteria to prove the concept, and then do the evaluation of the RFID hardware which you're planning to install. And then you have to locate the best place on your product where to place the tag so that there's no problem in scanning wherever it is going. Then test and evaluate printer and labeling solutions. Analyze the effects on our IT infrastructure, and then analyze full system implementation, and you are ready. RFID system design and the key areas are the 8 key areas: operation type, data quantity, programmability, data carriers operating principle, sequence, power supply, frequency range, data transfer. This is how, and there is a lot of interdependencies of these important factors are, so you can see how they are interdependent on each other. This is how typically the RFID tag looks printed, RFID printing. And application of printed electronics has given birth to several terms such as smart card, smart label, smart packaging. Nowadays, RFID antennas are either etched or printed. The good thing is RFID printing is less expensive as compared to etching. Some of the most common techniques for printing are flexography. Flexography is quite popular. And then the flat and rotary screen and gravure is also possible. Most of the time the printing is undertaken on polyester because it's quite heat stable and dimensionally stable. Antennas are printed on roll to roll and further run through the machine which glues the chip to the antenna. Printing should be undertaken directly on the product and its popularity is expected to increase. So that is the new things could be there, that if you can print the RFID directly onto the product, then nothing like it. Say, for example, on the plastic bottles. Printing of antenna involves use of a special conductive ink containing aluminum, copper, or silver, and in some cases the ink needs to be heated after printing. The market for printed labels is expected to get aggressive in the coming future as it will find usage in several sectors. And in fact, it's already going up because in the pandemic for the COVID. I think some vaccines are already using this technology to track and make sure what is happening, and it is also used in the hospitals. Typical RFID applications, badges, smart keys, we have access cards that typically RFID based. We use it of toll plaza, we use it without knowing we had been using it for so many years. Agriculture, livestock tracking is, I think this was one of the first ones which was used very actively. Asset management, maintenance, aircraft, intelligent toolbox, and for coming home for the packaging, inventory control, logistics, then counterfeiting, RFID in packaging industry. This is the way infrastructure would look when you have this RFID tag on a product. That is how the whole data going to ERP through the different meanings. Application of RFID in packaging. There could be paper thin labels can be integrated virtually anywhere into a product or within the packaging so as to not detract from the product range or the marketing messages. The techniques of source tagging offers retailers and manufacturers invisible and tamper-resistant security labels. This is a big thing because you can, I think, almost can eliminate counterfeiting with the help of this. Then source tagging can have many other benefits. By integrating RFID technology into the source tags, products are not only protected from theft, but can be tracked throughout the supply chain, providing visibility, vital inventory information to retailers. RFID enables retailers to not only know that theft event has occurred, but also what specific merchandise was stolen. So for that, they don't have to really unload the truck and count everything. They can do it from the distance and they can do it much faster. Consider one supply chain scenario involving the movement of a dairy product from the farm to the processing facility to packaging operation through distribution and eventually into stores. In each of these steps, there is movement of goods requiring shipping notification, goods received, inventory management, reusable asset tracking, cold chain management, and more. RFID improved each of these processes, integrating with existing enterprise systems to provide real-time insights. So, RFID helps you to get the real-time insights into the movement of goods without the need for manual processes that inherently cause latency and inaccuracy. Then we got to optimize the tag placement and orientation. RFID tag placements is not the same as for barcode labels, which are traditionally placed in the lower section of a case. Movement helps elevate RF nulls or dead spots, much like a cell phone, whereby an RF dead spot may result at a particular location. Dead spots typically are not as noticeable while the phone is in motion. It is generally easiest to read the tag when there is a direct line of sight between the tag and the reader antenna. This is referred to as the near sight. But unlike barcodes, line of sight is not necessary. So you can be near the antenna, but you need not be really in the line of sight. So that is the difference. RFID performance benefits from air gaps, generally at the top of the typical case, furthest from the conveyor metal and above aqueous material. If you're tagging parts of foil or metal, you can sometimes take advantage of the reflective or waveguide properties and actually channel the RF through the product to enhance the tag's performance. It all depends, we have to see. Tag orientation also impacts read range. Always vertically orient dipole tag antennas, horizontal orientations are prone to misreads due to perpendicular or cross presentation. So this is continues. Basically, keeping the packages safe from thieves is one of the key things. Shops, lifting, security concerns. So by implementing RFID into source tagging, retailers can maximize the speed to shelf and security of a product while maintaining the integrity of its packaging and design. The technology is fast, becoming the first choice due to its integrated benefits along the supply chain in addition to the in-store advantages it delivers. Source tagging is the best solution on the market to meet the needs of retailers as well as that of the brand owners. It effectively protects retail profits and the packaging image. After all, if a product is not on the shelf, it's not there to buy. So if once you have RFID tagging, you easily know where the product is missing. These are typically the leading RFID markets. You can see the distribution, pharmaceutical, airline baggage, manufacturing, military, government, retail supply chain. Some of the case studies, there was a business issue, labor and time intensive inventory processes, product placement errors leading to aged inventory and lost product. Solution, RFID enabled dock doors, conveyors and forklifts for automated routing and item tracking. Location visibility with RFID arrays strategically placed in floor and storage zones. Benefits, improved inventory visibility and accuracy. Operational savings for a distribution center could be something like 20%. Manufacturing, inbound to receive of different parts, no visibility of key components through the manufacturing process. Solution, RFID tags attached to parts, paper travelers, readers installed at various choke points. Benefit, system reduce receiving time from 4 days to 4 hours. Improvement of inventory accuracy, reduction in operating cost. So there are different benefits like in-store visibility improved with 64% of stocks out to 22%, improving the sales. FDA, pharmaceutical item tracking, we have been listening and maybe expected FDA mandate to track prescription drugs. This could also, once this will happen, this will also help in a big way. Pharmaceutical item tracking. The RFID pharmaceutical tracking market is growing very rapidly due to a new set of motivators. This market differs from the more frequently discussed RFID supply chain management market, made up of suppliers complying with the retailer mandate. Pharmaceutical companies have more poignant concerns encouraging them to adopt RFID. Major motivators are ensuring patient safety, eliminating counterfeit drugs from the supply chain, enhancing the safety and security of the pharmaceutical supply chain, addressing emerging regulatory requirements, optimizing supply chain process in general. So this is another supply chain visibility where you can use it. Visibility of supplies at the case and pallet level to support the war fighters on a global basis. Then retail, and then increasing inventory velocity from the DC to the retail store and onto the shelf. So more efficient. This is some examples in practice from China Medic Farm of using smart labels with NFC. So NFC is, I would say, it's kind of RFID sister, near field communication, and which does not store any data or there's no battery, and labels integrated with NFC tags connect to devices over short distances, like it could be your phone. So it's not emitting any data. It gets active only when you bring your phone near to it. And it is based on established RFID standards, ISO, and convenient smartphone readability. It can be on the Android or iOS. So there are three different use cases combined in one label. You can do user interaction, patient, healthcare professional, device interaction, infusion pumps, laboratory equipment, supply chain logistics, exemplary manufacturing laboratories, retailment samples, pharmacies. Then it could be used for tamper evidence, like to authenticate label unopened, authenticate opened, and authenticate label opened and reclose. When how this is done integration of additional sensor loops to record first opening or tampering of a product. Label integrity status can be read via smartphone. So once there is a seal, say for example the pen label, when the patient opens it, it will say it has opened, and then it will check the integrity, and then it's done. So it cannot be, counterfeited, because both the things have been used. Improvements of supply chain, which we had been talking, time and labor savings, increased control, flexible product flow, enhanced customer service and security, better tracking, reduce inventory, shrinkage loss, reduce counterfeiting. RFID enterprise benefits, again, supply chain efficiencies, improved customer satisfaction, increased sales, helps in decision making and business process. Now, e-pedigree, I'll come, you might have heard for the e-pedigree a lot, and for the e-pedigree, RFID is great. What is e-pedigree? E-pedigree in electronic pedigree is a secure record documenting that a drug was manufactured and distributed under safe and secure conditions. The aim is to try to reduce the introduction of counterfeit drugs into the illegitimate pharmaceutical supply chain using e-pedigree EPC tags by sealing a bottle at the manufacturing plant, affixing a tag with a unique EPC, and using RFID readers to track it to the wholesaler and eventually the pharmacy. The manufacturer, wholesaler, and pharmacy can ensure that the product is genuine. So the moment this is done, this can follow into the e-pedigree. And mandatory labeling means that pharmaceutical companies have to generate billions of unique serial numbers, printing them on packages, and store the history of every single medication. Coping with this enormous flood of data requires the use of a powerful fail-safe systems capable of satisfying the wide range of requirements in the pharmaceutical sector. Implementing such solutions involves a number of challenges for pharmaceutical companies. So the product that takes data from RFID readers filters out redundant reads and passes and event data. Information about the movement of products, say, to an application, the pedigree application gathers and stores a multitude of information about drug sequence. So you could see actually, it makes the life much simpler. If you have RFID, you don't have to, really go through it and filter it. Your software and system will take care of it. You have to just bring it near to it. Like Florida law requires companies to capture and store the name of the person who signed to receive the product at the pharmacy. So if they are on this, they can easily do it. They don't have to write out everything, fill up the forms. The standards for RFID. There are different type of standards are required at different places. Key areas for the standards are air interface frequency standards, data content and encoding, conformance, testing of RFID system, interoperability between applications and RFID systems. And there are several standard bodies involved in the development definition of RFID technologies, which is like ISO, EPC Global, in European Telecommunications Standard Institute, FCC, Federal Communications Commission. Obstacles and challenges for the vision. The signal disturbance, standardization, cost, privacy, data management. These are some of the obstacles to implement this. The standardization, two areas that require attention when discussing RFID. Allocation of the radio spectrum and the standardization of RFID communication system. Then signal disturbance, privacy, cost, data management. Now, coming to this RFID versus barcode, this is barcode. It has to be visible. RFID, it can be hidden somewhere inside. Maybe you don't have to look at it. This is the inside thing. Now the question comes, will RFID replace barcodes? I think everybody agrees kind of thing that they will coexist with traditional barcodes for many years to come. RFID is an extension of barcode data collection system. Barcode is a system. RFID is just a collection method, but the methodology is same. New RFID label printers marry these two technologies for the best of both the worlds. A quick comparison of RFID versus barcode. RFID faster reading as they can be read simultaneously. Barcode, you got to go through them one by one individually. RFID, we talked about it, no line of sight required and must be visible to read. Then RFID can deal with rough and dirty environments. Barcodes need cleaner area. So there are advantages and more advantages of RFID tags. I think the best which I like is simultaneous identification and no line of sight. Of course, data storage, read, write, reliability, durability, difficult to copy, security, everything is important. But the key thing is these two, which I think personally from my point of view, that in one go you can scan hundreds of them. Simultaneous identification, which we talked about it. No line of sight, data storage, read, write, read, reliability, durability, difficult to copy. Like we have noticed that linear and 2D barcodes have been replicated by counterfeiters by simply scanning and printing them. But that is not happening in the case of RFID tag manufacturing. So what it is required to take the advantage of RFID tag? Simple thing, I think the step which you have already taken, learned, technology. Think how RFID will impact your business. So we talked about it from the team. And then plan to integrate RFID into your business. Disadvantages, of course, expensive compared with barcode. Could be bulkier depending. Prone to physical electrical damage due to environmental conditions. So we have to see where we are using it and how it is protected. Sometimes it could be interference has been observed with devices such as forklifts and walkie-talkies are in the vicinity of the distribution centers. So like in US, Europe, they have different range of frequency that allow RFID tags to function. Metal and liquid have an influence on RFID, and we might have to go for a special tags. Some people call RFID an invasive technology, and consumers are apprehensive about the privacy when they purchase products with RFID tags. Once a radio chip is installed in the product, the customer could be tracked by RFID readers. But I think this is more a hypothetical problematization than actually the problem. Future of the RFID technology. Researchers from the Chung National University, South Korea, and Rice University, Houston have developed a radio frequency identification that could replace the barcodes on groceries in stores. The tag, which can be directly printed on grocery items, uses ink containing carbon nanotubes that could instantly transfer information about the contents of a grocery cart. So there are many developments are happening. So future like this, future seems to be great, which we can already see. This pandemic has already increased the value of RFID, and because it's non-contact, and especially in the e-commerce and the airports handling and the speed which you need. So and like any other technology, many of the technologies continue to evolve. It's coming through chipless tags, conductive inks, tags integrated into corrugated and packaging, multi-frequency tags, semi-active, dust networking, and so on. These are some of the major players in the area of RFID. This is not a comprehensive list. This is some of them which we picked up through the internet. And this is our reference list. This is not again the exhaustive. We have put some of the key references which we have used to prepare this presentation. I hope this was useful to you. And with this, I would like to thank you and open for the questions. And I will just unmute you 1 second. I have unmuted you also. Now you can unmute yourself and ask any questions if you would like. There's a question on outdoors. I didn't really get what you mean by outdoors here, but any item has to be RFID tagged before it is scanned. So there is a question that whether when you apply this RFID on a, say, the cylindrical form or something, they say on the pen device, will the circuit break? So I think there is a possibility to make sure that anti-rolling mechanism into the system so that circuit will not break and it can be protected. And using it on the liquid filled drugs, yes. So that is also possible. Saying, can you apply it on the regular labeling machines? Yes. Now you get the RFID tags, quite flexible, which can be integrated into the label, and existing machines can be used without damaging it. Not able to see the screen. I don't know, Saurav. Because maybe you check your internet, because I think other places it is being seen. Oh, okay. Any other question?
Yes. How does your company assist in setting up? Say, for example, if we have a requirement, how would your company be able to help us?
And what kind of which area you want to implement this?
See, basically, we have spare parts for machines with us. So we need some kind of a system where, where we know that where all the parts are kept, and and if they left the premises, then where they are presently. So, is there any way you could help us?
I think yes, we could do it. And let me see. I think, Arne, are you online?
Are you talking to me, please?
No. I think there was somebody, Arne from Shanner. If I was just looking if he's still online, they could give you the example. Anyway, Arne, can you unmute yourself? I think you cannot hear me, but it is possible we can discuss it offline, and it is possible to, because we are focusing mainly on the pharmaceutical, but I can check with our principal Schreiner in Germany whether they can also help you on the spare part, because basically the technology is same. So if you can send me a short message or email later on, and then we'll try to respond to you, Ashish.
Okay, excellent. So your email ID could be found at the Sanex Packaging Connections Private Limited.
Yeah, the email, when you register,
on your website. Am I correct?
When you register, you will see our email there.
Okay, fine.
Info, and I just noted in the chat box also. And we will be sending you a follow-up email where you will see all the contacts.
Okay, excellent. Fine, we'll do that. Thank you very much.
Yeah.
Yes,
Thank
please.
you.
Yes, please. Thank you.
Any other question? Anybody? Okay. So I think it looks to be good to go. Then I once again thank you everybody, and have a great day. Bye. Thank you. Namaskar.